Hi everyone, in this example I'd like to find the inverse of a log equation. So we're going to find the equation for the inverse, which will involve solving a log equation. We'll check the composition of the function in inverse, which often involves some log properties, and then we'll sketch the function in inverse. Okay, so if I want to find the equation for the inverse function, I'm going to switch my x and y and then solve for y. Since I only have a single lonely y sitting over here on the right-hand side, I'm just going to reverse order of operations. So the order of operations here is I take a y, I subtract 3, I take the log base 1/2 of that, and then I multiply by -1. I'm going to peel those off in the opposite order, so I'm going to divide by -1. I now want to get rid of a log base 1/2, which means I exponentiate with a base of 1/2. So I get a 1/2 to the negative x. And then I'm just left with the y minus 3 on the right, which means I have 1/2 to the negative x plus 3 for my f inverse. Okay, since the compositions talk about domain, I'm going to go ahead and list the domains right now. For the inverse, it's all real numbers. You can plug anything you want into the exponential. For the log, the x has to be greater than 3. This is because x minus 3 has to be greater than 0. Okay, so f of f inverse of x. F inverse is a 1/2 to the negative x plus 3. I should point out that you could turn 1/2 to the negative x into a 2 to the x, but I actually think that will make your life slightly more difficult when you're checking the f of f inverse. It will make the canceling a little less obvious, so I wouldn't even bother with that here. Okay, so the f function takes the negative log base 1/2 of whatever I give it, and then it subtracts 3. Actually, I'm saying that in backwards order. It takes whatever I give it, subtracts 3, takes the log, multiplies by -1. The first thing to go here will be the plus minus 3. The next thing to go will be the log base 1/2 of 1/2 to a power. So the negative out in front will still be sitting there. The log base 1/2 and the exponential base 1/2 wipe each other out, but the power I'm left with is a negative x. So there's what I was hoping for. F of f inverse of x is equal to x. I am also supposed to say when that will be true, what the domain for that is. It will be true as long as it's legal to plug our x into the inner function. I can plug whatever I want in here, so it's just the inner function that might have problems, but it does not, in fact, have problems. It's exponential, so this is true for any x I might choose. I want to also check the other direction, so I would like to find f inverse of the original function, negative log base 1/2 of x minus 3. Which will give me a 1/2 to the negative, my entire input, and then plus 3. Okay, so the first thing to go are the minus signs. Multiply -1 by a -1, and they're gone. So we have 1/2 to the log base 1/2 of x minus 3 plus 3. The next thing to go is the 1/2 to the log base 1/2. Those wipe each other out. I'm left with an x minus 3 plus 3. Don't really need the parentheses anymore. There's no powers or multiplications or functions attached to them. So we can just combine the 3 and the -3 and say f inverse of f of x, again, equals x. This is looking good. Here, the inside function is the log function, so there are actually restrictions on this. It's only true that when you compose, you get back x if you're starting with a number bigger than 3. Otherwise, you'll get stuck right when you go to the original function and have to say undefined. All right, last part of this one is to sketch both, and hopefully we see them looking like inverses, looking like if we flip one across y equals x, we get the other one. So this time the original function was the log function. So I'm going to picture a log base 1/2, which is this decreasing log shape, has a vertical asymptote at x equals 0. It goes through 1, 0, and 2, -1. You can choose any points you like, but 1, 0 is easy. And the reason I'm saying 2, -1 is I'm thinking about plain old log base 1/2 of x. Log base 1/2 of 2 is -1 because 2 is reciprocal of 1/2. Okay, so I need to flip this graph upside down. So I'm actually picturing the increasing log shape now and shift it to the right 3. So flip my y's. So let's change the sign on our y's and then take the x's and add 3. Okay, so the vertical asymptote. If I flip upside down, it's going to look exactly the same. If I shift it to the right 3, I'll now have x equals 3 as my vertical asymptote. Okay, 1, 0. If I flip upside down, that stays put. If I shift it to the right, it goes to 1, 4, 0. Sorry, say that one right. 2, -1. If I flip it, it lands at 2, 1. If I then shift it to the right, 1, 2, 3, it lands at 2, 5. Okay, so I have an upside down version of this shape, so it's going to head off this way with its vertical asymptote at x equals 3. All right, so there's the log graph. Again, you should just be able to flip this across y equals x to get the shape of the exponential, but a really good way to check is to try and do your transformation, sketch the exponential, and make sure it really looks like what we would expect it to. So now I'm thinking take 1/2 to the x, which is that exponential decay shape. It goes through 0, 1, and -1, 2. We're going to flip our x's, and we're going to shift our y's up 3. So if we flip our x's, the horizontal asymptote doesn't move, but when we shift up 3, it will move to y equals 3. 0, 1, when we flip our x's, it doesn't move, but when we shift up, it lands at 0, 4. And -1, 2, when we flip, lands at 1, 2. And then if we go up 3, it lands at 1, 5. 1, 5, hold on, I think I've misplaced a point over here. 2, flip, 1, 5. I did. This should go through 5, 1, not 4, 1. Okay, so if we connect here, there's the log, and they do in fact look like inverses. This is a great sign. I do want to be really clear that the horizontal asymptote only applies to the log. Only applies to the exponential. The log will work its way up slowly, but it will eventually get up to y equals 3 and cross it and keep on going. And the same thing with the vertical, it applies to the log. The exponential will eventually cross that and keep on going. So there's my pictures. Looks like I got inverses. Thank you for watching.